Hello, everyone. I'm Deep Medhi. I'm the organizer of the SKC Science and Technology webinar series with a small team we have, Manojman Kolita, Uddipana Goswami, and Manavendra Sohoria. Today, it is my pleasure to have Dhruba Borthakur, a very accomplished engineer, and a lot of things he has done over the last quarter century. He's currently the Chief Technology Officer and also the co-founder of Rockset. And he has done a lot of things, actually. One of the early people who worked, co-founding engineer of, with the group on Hadoop file system and worked at Yahoo at that time. And then went to join one of the first employees at Facebook, I presume. He can tell us more about it when he started at Facebook and how he took it from implementing Hadoop in Facebook and then went from, as his title says, from batch analytics to streaming to finally real-time analytics. So with that, I think we're going to hand it off to Dhruba to get it going. And one more thing, we try to do it like a fireside chat format. So I'll stop you, ask you questions, clarify things, and other people can put questions in the chat as well. Okay.
Yeah. Hey, thank you, Devu. Thanks a lot for the introduction. Can you guys hear me loud and clear? Got it. Okay. Yep. So I have a set of slides. I'm going to talk about analytics in general, like how analytics has evolved over time. But again, my goal is not to go through all the slides and finish them. My goal is to see if I can get more interactive and help answer your questions. So, Debu, if you see any questions, please interrupt me and like ask me, or maybe just like orally, so that I can kind of stop what I'm saying and maybe
I will do that. Yep. Great.
Cool. Yeah. Thank you. So, a brief introduction about myself. Let me see if I can move the slides. Yeah. So currently I'm in a company called Rockset. I've been there now for the last 5 years or so. It is a company that mostly deals with real-time analytics. But before Rockset, I was at Facebook, which is now called Meta, of course. But Facebook, I joined Facebook when it was very small, probably around 100 or maybe 200 engineers, or total size. So the number of engineers were small, and so it gave me a lot of opportunity to kind of do or look at how engineering software and team scale in that company. So I spent around 9 years at Facebook, but before that I was at Yahoo. I worked there for around 2 years. I joined Yahoo when it was it just started a project called Hadoop, and there were like 1 or 2 people, and then finally more people joined the team. So I saw the growth of Hadoop from kind of the first user who started to use Hadoop till the time when it became so big and quite well adopted in the industry. And before Hadoop, I was at a company called Transarc Labs. It was a distributed file system company where I worked on something called Andrew file system. I also worked in Veritas software, which is a kind of storage. So my background has mostly been storage, servers, these kind of technologies, and building how I've kind of seen from close how data systems have evolved over the last 20 years or so. So in this talk, I'd very much like to answer questions about how things have changed, how things were, and how people use data more often now in real life or in their day-to-day life. Those are things I really wanted to cover. I have broken up my talks into like 3 parts. Essentially, I'll talk a little bit about how data analytics have changed over time. I'll give you real examples of real-time analytics. What does it mean? Like sometimes we don't realize how analytics are affecting our daily life. And then I will also talk a little bit more technical details about number 3, which is about some requirements that people usually need to use or leverage for implementing real-time analytics. So essentially, that is kind of my outlook or the overview. Any questions so far?
No, that's good. Very good. Yep. So look forward to hearing about it. So
yeah, sounds good. So where has data processing been? So if you look at big data essentially started around like 2005 or 6 or somewhere around there. Before that, people mostly used to store data in transactional databases, right? You use your credit card, it gets stored in a transaction database. But since the evolution of, or the starting of Hadoop, that's the time when people started to use data more for analytics and not for transactions. So analytics is basically mining the data and extracting information, or analyzing data to extract information out of it to see how it can be used. It's very different from, say, when you go to the bank and you withdraw money and you take out cash. That's very much a transaction. There's no analytics there, right? You have some account, you go swipe your credit card, you get some money in your hand. That is like some amount gets deducted from the data that the bank stores on your behalf. So that's how most of the data systems were before 2005. And 2005 is when Google produced some very seminal papers on big data processing, which is about GFS and other things I'm going to tell you. But essentially 2006 to 12 is when a lot of big data processing started.
So
Hadoop was,
when you started with Hadoop first about building it, what was the set of data you were trying to process? And
great question,
what sort of answers you try to guess? And also the size of the data at that time. It's like 16 years back. If you can tell us a little bit about that.
Yeah, absolutely. I will tell you a little bit history here then, right? So I remember the first user of Hadoop, he was actually an intern in the Yahoo search team. And I was working with him. He was the first user of Hadoop because that team, the search team, hired an intern and said, hey, these guys are building something called Hadoop. See if you can use it. Let me know what's going on. So that intern was a super sharp person, of course. It was a pleasure working with him. But he was the guy who kind of tried to look at how Yahoo builds the search engine. So Yahoo at that time was a search kind of an app or website, right? So you can type in something and it shows you the results. So they started to use, before Hadoop, they were having their own custom code to be able to index all this data, but then Hadoop gave them a platform where the infrastructure is separated from the application, right? So the infrastructure is the Hadoop infrastructure. So the application, which is how actually the index is built, is separate from the infrastructure. So it's easy to scale up. I think if I remember right, most of it started with like a 3-node Hadoop cluster, if I remember right. And the intern was able to do a lot of things in those 3 months he was there in the summer, I think, of 2006. And then quickly showed the usage of Hadoop to other people in the team, right? So other people realized that, oh, this is interesting technology. So then they kind of started a full-fledged team in the next 3 or 4 months afterwards. But the first use case was building an inverted index for Yahoo's search.
I see. Okay.
I have more detailed examples of how some more examples, Yahoo ad optimization. I'll come to that in my slide. So basically that's how it started. And then what has happened is that in the last maybe 2012 to 2018 or even now, a lot of things have moved to becoming more real time. So Hadoop was very much a batch processing system, right? There wasn't any focus on how to make things fast or quick. The focus was how to find some value from all the data that I have. But since 2012 and 2018, there's a lot of processing about real-time processing. How can I find or extract value out of my most recent data sets? That is definitely one change. And then, of course, now going forward to like 2020s, there are more real-time analytics, and I'm going to talk a little bit about those as well. So batch processing. So I worked a year or maybe 2 years at Yahoo, and then I joined Facebook at that time, right? This is 2007, I think, somewhere around there. I joined Facebook, or 2008.
2006.
So
2008, yeah, right.
2008, I think I joined Facebook. So 2008, Facebook was very much still trying to figure out how to get value from the data that they are storing, and the value and the fact was that one of the very interesting applications that Facebook started to build was something called PYMK. So people you may know. You can look for it. It's kind of there's a lot of write-ups on this project later on the
right,
web, on
right.
Google
It's
search.
one of those early things. Yep. Right.
It's very early thing. Here I have a link at the bottom of my thing. This talks about how much controversial this project became later, right? But as a technology person, I was really excited to do this project because, first of all, the way it worked is that if you have 5 friends and your friends have let's say you have 5 friends and those 5 friends have 5 other friends. So if there are certain events that those friends of friends go to, then it's likely that you might also want to go to those events, right? So this is how you kind of build a social graph. This is called the Facebook social graph. And it was, so looking at Facebook's posts and comments and connections, this graph needed to be built in the backend. So once you build this graph, then let's say I am connected to Debu, Debu is connected to Scott, let's say, right? So then this graph processing will tell me that I should also be connected to Scott, which is Debu's friend, right? So it is basically, and it will suggest me when I go to my Facebook app saying that, oh, you should be friends with Scott because it's likely that you 2 guys have some common friends. So right. This kind of processing was very large. I mean, the data set was very large. And the value add of finding these simple connections was great in making Facebook grow in the early days. So at that time, there was a lot of competition from some Orkut was there, some other, maybe some, I forgot some of the other ones, Friend Feed, there were some other social.
MySpace. Not MySpace.
Yes, MySpace.
That's right.
Yeah. So this was, I think, one of the seminal applications, how Facebook grew faster than the other like social media, because they were able to find value for the people who are using it. Like suppose like they could actually find relevant value for people, and so the connections grew a lot. All of this was very much batch processing. So you would take all the posts and comments like that happened, let's say the last 1 week, and then process it for 1 day in this Hadoop cluster. And then you find out that, oh, I should be friends with those 3 folks, and then the application will show up on my website saying that, hey, Dhruba, do you want to be friends with these guys?
Okay.
So here again, it needed a lot of storage, and it also needed a lot of compute to be able to find these hidden kind of links.
But I think it's important to point out, Dhruba, that just having the compute power is not by itself enough. Even if you have a lot of compute power, that was not, you have to still build the algorithms and all the processing information to be able to do efficiently, even in a batch processing environment. So that's an important
absolutely. Absolutely, yeah, absolutely. There's a massive amount of data and massive amounts of compute needed, right? So just having the data and compute is not sufficient, because it's the logic and the heuristics or the models that you build, saying that otherwise the effect of this algorithm is not very good, right? If you suggest some random people to be your friends.
Right.
So there were things like what common events people go to, what common books these people are reading.
Right.
And did they have Facebook also had like which schools you have been to. So if you find common patterns in the schools that you have attended, then also there is a stronger relationship between people. So all these were part of the model, which is why it needed so much compute. So the model is the interesting part, I mean, from the application's perspective. So it was very much batch processing in nature. And if I look at the batch nature of things, I did a little bit more technical description here, is that this is not directly related to how Facebook ran it, but in general, Facebook also had a software called Cassandra. It was basically a key value distributed database, which is what I show it here. But so what will happen is that if you look at it from the left side of your screen, there's lots of data coming in through log streams or some other external sources, and then there's a lot of processing that happens. as part of building these models. And then finally, the models are built and then they're parked in, let's say, an online database like Cassandra or somewhere else, where when you go to the Facebook website, that website mostly hits the Cassandra database, for example, right? Or the MySQL database to fetch data. It doesn't hit Hadoop or anything. Hadoop is very much a batch processing system. So this is where the difference between the batch processing analytic systems, which are kind of on in the pink color or somewhere there, and whereas on the right side, it's where it's actually analytics serving, and that's happening from to your website. So now I will switch over to tell a little bit about one of the use cases that I had when I was at Yahoo, right? So this use case started when I was at Yahoo, but actually became full-fledged much later, where it used a lot of real-time processing. So when I was at Yahoo, like I explained, the first use case for Hadoop was building this index so that you can search the web quickly. But then the second use case, which happened, was ad optimization. So what is ad optimization? Ad optimization essentially is that if you're a website and your revenue model is to advertising, right? So the goal is for the company to show relevant ads to you, right? Like suppose you want to buy shoes, they should be able to show you like a retail advertisement rather than like Flying Club or something else, right? So the focus is how can you show relevant advertisement to the people who are logged in. And usually the process works like this. Like let's say I am a shoe manufacturer. I place a campaign on Yahoo's advertising engine saying that, hey, I want to show my ads. I want to spend $100 per day to show ads, right? So now Yahoo has to make sure, the infrastructure has to make sure that it shows, let's say $100 buys you 100 ads. I mean, it could be completely different, but essentially Yahoo has to make sure that it shows you 100 ads per day. So that means Yahoo has to calculate how many ads has already been shown till now and how many are left, so that they can show accurately the amount of ads that they're supposed to show. Now, this is very complicated when it's a distributed system, because there are lots of people logging in from all over the world. And so counting and summarizing how many ads have been shown for every ad based on, again, all the ads have a lot of things. There's demographics of users. They want to show 50% to people who are less than 19 years old, then 20% to people who are female, let's say. They have all these demographics. And so the counting has to be done on many different aggregates in real time so that you can show the right amount of ads.
So the interesting thing is that as we grow older, we realize that counting is the hardest problem. We thought when we were in kindergarten, we thought, okay, I can count, right? Now counting has the most interesting problem because of all of the special cases, what needs to be not counted, and everything, and doing it on a massive amount of information, right? So
and scale, yeah, very difficult.
Right?
I think counters are super important. Yeah, absolutely. Again, not one counter, like you said, right? There are like hundreds of counters per ad, and everything has to be accurate. Like again, estimates are good, but there are certain, the more accurate it is, more better is a solution you are building.
Correct.
So at that time, again, Yahoo had like 26 properties, if I remember right, which is properties are basically like Yahoo Real Estate or Yahoo Finance, or Yahoo something. I forgot all of them, but everybody, the business model is to show ads when people visit their website, those properties. So the problem was that data latency for counters that I explained. Those data latency for counters are like maybe an hour old, right? Which means that if 100 people saw the odds ad in the last hour, it won't be reflected in the counters after an hour has passed.
So there's a lag of an hour.
There's a lag, correct. So there's a lag of an hour. So now just imagine so think about it. So actually Yahoo is kind of showing more ads than what is needed now, because let's say they're supposed to show 100 ads per day and it's 11 o'clock in the night. They're not really sure whether they have shown 100 or not. So they will show more and then later on they realized that, oh, I overpaid for all this. I mean, I gave more goods to the user versus what I'm supposed to give. So this was like around 15-20% overpayment, and in the beginning it was like 2x overpayment, but over time it has got reduced to 15-20%. Again, the focus was how can you make it more real time? So instead of Hadoop doing these computations, how can you use Kafka? How can you use streams to be able to get this lag from an hour to a few minutes or so, or maybe 10 minutes, 15 minutes, something like that, right? So that was a great use case, and most people also followed. Many people outside of Yahoo or many other applications also kind of followed the same model, saying that how can you use Kafka, how can you use streaming to make more real-time processing rather than using Hadoop for batch. Real-time processing is also difficult because although you have, so Kafka is like a streaming system. You might have, some of you might have heard about it. It's an open source software that came out of LinkedIn. Many software companies use it. Hadoop, definitely a lot of people use it. So the way most of the architecture are set up is that data comes in, they get parked into Kafka, and then it gets drained into either Hadoop, which is like kind of long-term storage now, or it gets into like Spark, which is modeling. Like we talked about how we can build models based on all the data that have arrived. And then they get parked into this.
Let me kind of go into the streaming. The batches we understood is very clear. You do ahead of time, you know, you got some result and you display it, you know, 1 hour late, 2 hour late, whatever it is. Now, when you are going to what is called the streaming, which is not real time, but you are trying to move closer to real time, but not quite there yet. That's basically the idea of streaming. You are streaming something, but not to be confused with streaming like a movie streaming or something. It just means a data streaming happening, but the data streaming is being processed almost near real time. And so, but not quite real time yet. So, right. And of course, absolutely. The Kafka, you know, different engines are used like Kafka and stuff like that as to make it work. So I guess the one quick question is that what is about Kafka that allowed to move away from batch processing? I mean, very fundamentally, what is different in Kafka that allowed it to move from batch processing to streaming idea to make the next leap, basically?
Got it, yeah. So for batch processing, it was something called MapReduce, right? So it was a framework that Google invented or wrote about it widely. So the MapReduce is essentially a way of scanning a lot of data in parallel using something called map tasks, right? So that was kind of the computing paradigm. So Kafka said that, no, that is great if when you have a lot of data and it's like for batches. For streaming, that's not good. The computing paradigm for streaming is that it's a FIFO queue. So you send in data from one side and you can take it out from the other side in the same order. So it's like, let me give you an analogy, right? So let's say you have like pipes in your house which get water, right, from the mains.
Right.
So those pipes are usually not built to kind of transfer huge amounts of data from, say, Niagara Falls to San Jose or somewhere else, right? They're mostly built so that they can distribute data very quickly from the mains. It's kind of a flow system. It's like a data flow system, rather than scanning, and which is what Hadoop essentially proposed. So the basic difference in Kafka is that it's a distributed log. You put in data from one side and you can take data from the other side, wherever you are. It is distributed. So if you're putting data here and the other side of the pipe, the water is flowing out and you don't have to do anything. You just have to keep reading record by record.
Right.
All this infrastructure is handled by the pipes, which is basically Kafka. So Kafka is like a big set of pipes that you can connect from one place to another.
Right. That's a very good analogy. Good.
So basically, so for streaming, the architectures mostly said that, yeah, we will continue to do batch using Hadoop, but we complement it using streaming architecture, which is basically like taking Kafka along with it and doing a batch, let's say once every night at 12 o'clock midnight, but over the course of the day, we are going to keep using streaming to be able to supplement our counters, to keep our counters accurate, like the analytics counters. But it's not that easy because now people have to write two sets of code. One code which will process all the data that's coming through the Hadoop pipeline, and the other piece of code which has to handle all the data coming through Kafka and whatever Spark and something else. So basically people have to write two versions of the same logic in two different ways. One which is handling MapReduce and one which is handling these pipes from Kafka. So there's kind of a different program for the application to be written. So that's a problem, right? Now, but it still works when you're talking about streaming latencies of an hour. Let's say you are looking at streaming latencies of 15 minutes. This is a fine thing to do. But now, over time, we have seen even more applications who need even faster data latency, which basically means that it has to be real time rather than streaming. So I'll give you one or two examples of real time. Let's say there's a fleet management system. So these are again real use cases that I'm talking about. These are some of the use cases that are actually there at Rockset. So the fleet management system. Let's say you have say 10,000 trucks which are delivering cement from one place to another, right? Right. So now you have to. So it's an analytic system where if one truck is out of order, or something is leaking and you know that you cannot make your deliveries in time, how can you make sure that you can reroute that shipment through some other trucks? Because again, cement has like a lifetime. Right, like if it's more than 10 hours, it becomes hard or something, right? So it needs to be fast. It has to be deadline based, not just like send it whenever you like to send. Things like
yeah, same thing like with Verizon, the trucks that fix. We had to do fleet management real time.
Correct. Exactly. Yeah. Fleet management. Even like this also applies to like companies like Uber and other things at large scale, but I'm talking about very commercial applications here.
Yeah.
Right. So
in telecom, I mean, in Verizon, we had to have all this ready.
Correct.
So if one truck is out, the internet cannot be out or FreeOS cannot be out. So
correct.
Thank
exactly. You. Yeah. Exactly. Yeah. That makes sense. So how can you react to events that are happening in real time? So this is real-time analytics. So how can you make decisions immediately within a few seconds of a problem being detected versus waiting for 15 minutes for streaming analytics to take into effect and suggest a different routing for these trucks, right? This is one very good example. Another example that I have is analytics in online gaming. So think about online gaming, which are like playing games against, let's say, 50 players in an online game, and you want to show the leaderboard for your players, right? You want to say that these are the first top 10 out of the million users playing this game. Right. So those leaderboards, it can be 15 minutes old. Nobody will pay any attention to a leaderboard where if you're playing and you're winning, it doesn't reflect immediately. Right. Right. So this is again real time.
So because Hadoop won't work there because it's too late.
Hadoop won't work.
Too old.
Too late.
You need a new way.
Even streaming. Yeah, even streaming is very difficult for them to work because here we are talking about maybe a latency of 1 second or 2 seconds.
Right.
When you play a game, immediately it should get reflected in the leaderboards.
Right.
So this is again very much a real-time analytics use case. And the third one is essentially analytics for computer vision. So basically, I have a video. Let me see if I can play it. Can you see it?
Yep. This video. Yep.
So what is happening? I'll show you. So this is actually a real video of a company who is trying to do automatic checkouts from a retail store, right? So you go to a retail store, you pick up the goods from the aisle, and you walk out the door. You don't have to do anything. Your bill will automatically, your credit card will get charged.
Right.
So now there are computer cameras that are looking at the shelves, and they have to figure out in real time what is being pulled by the people and put into their shopping bag.
Right.
Right. So here, this is an experiment where people are pulling up mustard and all these operations, like people are pulling two things at the same time from the shelf and then putting it back. So see how the camera is doing some real-time analytics on what they're pulling Nutella, they're putting Oreos, they're handing from one time to another person. see, for example, they put something on the ground now, right? 2 items. He has to remember what those 2 items are.
Right.
You pass good. So he picked up, so he has to remember what he has picked up, and you throw it to other person, he has to know. The software has to know what is being handed from one person to another. And just imagine the amount of real timeliness that you would need here for analytical applications. Again, this is all video analytics. You look for hidden items. So the camera has to remember that there are certain things behind another object, so that when you grab it, you know that you're grabbing it. And then take, for example, I can actually make this bigger. Oh yeah, this is the fun part. So final inventory and checkout. So now the person is walking to the checkout store on the small corner on the right. So you'd see that your receipt immediately appears there and you don't have to do anything. So they remember, and now the person is going back and saying, I don't want these 2 items. I'm going to put it back on the shelf. The other guy, meanwhile, walked out with some Cheetos or whatever, and he says, yes, this is correct. And he signs out and pays the bill and goes away. So those are the things that this video shows, like single items, double item grab. So it's essentially what is happening is that the video cameras are getting video stream, and then there is a logic which translates these videos into a set of tags that are there, and then a model runs on the back end, which figures out the action that the person or the things or the scene is doing. And this is in real time. You cannot have any lags. So this is kind of the extreme example of real-time analytics, which needs specialized systems, not even Hadoop or Kafka or anything else, but very much video-centric specialized systems to be able to do real-time analytics. I wanted to show you because this is basically what a self-driving car can use, or things like those essentially uses to analyze what is happening. I'll keep this in the slide so that you can see it later at your own time. But it's a great video to understand how real-time analytics is actually permeated in our like day-to-day lives, every day that we do something nowadays. So now going back to any questions so far? Okay. So all these real-time analytics essentially needs 2 things. One is it needs fresh data, which means that it cannot operate on data that is a few minutes old or an hour old. So grabbing fresh data is kind of one of the first prerequisites of building like a real-time analytics system. So the challenges for building these kind of analytic systems is that there's burstiness of data, which basically means that sometimes data is coming at, let's say, 1 megabyte a second. Sometimes it will suddenly shoot up to 10 megabytes a second, or like 100 times more, and you have to deal with all those. And similarly, queries suddenly appear, more queries, because let's say in that example, more people are checking out of your store at the same time. Right. So there'll be a lot of queries in your data system to kind of handle that load. So I talked about the Lambda architecture earlier. So now people are mostly moving to this new architecture in the software land, something called aggregator leaf tailor architecture. So I will give some examples of how this architecture is used in real life. But the one point about this architecture is that similar to how, Debu, you asked about difference between Hadoop and say Kafka. Right. The difference between those systems and the aggregator leaf tailor architecture is that there are 3 things in this architecture. There are tailors, there are leaf nodes, and there are aggregators. So 3 different things, because each one of them handle 3 different things. The tailors handle a lot of writes coming in. Leaf handles the size of the data growing and shrinking, and the aggregators deal with more queries happening at the same time. Instead of deep diving into the architecture, I'll give you 1 or 2 examples of how ALT actually, it's called in short ALT. So why ALT for real-time analytics? I'll skip this slide. Yeah. So one of the examples of ALT is the Facebook newsfeed. So I think all of us are used to Facebook, the app where you fire up the Facebook app and you see all the comments from your friends and the family. So here, what happens is that the Facebook newsfeed is actually an analytics app. It has no transactions. It doesn't need any transactions. All it needs is the ability to crunch a lot of data and do a sorting, relevance, matching, and then rank them based on your interest and the connections who are posting it, and then show it to you on the app. And what we found at that time is that if it is real time, it has like 20x better engagement than when you show data which is stale, which is 10 minutes old, 15 minutes old. So this is one of the primary use cases that I saw where a real-time system on huge data sets can actually drive engagement so much. And what it does is that the system, again, uses an ALT architecture in the backend. It basically, when people are posting comments or liking photos, they're all going into this ALT system. And then there's a relevance matching, which is a model that runs on these things in real time and then shows you the feed. So the Facebook news feed is not built upfront. It is built when you log into the system. When you refresh your screen, a new data appears immediately. So it's not like pre-built and cached for many minutes that you keep seeing every time you refresh. So you actually see real-time data. And ALT, the aggregator leaf architecture, I think this was the first time I saw that architecture actually running in production at a very large scale. Also, there is LinkedIn. LinkedIn also has something called the follow feed, which is basically what all people are commenting about posts and things like that. That uses exactly, or used to use the same architecture as Facebook. Over time,
probably
it might have
Twitter
changed.
Also, same thing, right?
At a certain point in time, yeah, exactly.
Okay.
I think all of these social media are things which needed real-time analytics. All of these are actually analytics applications. Like think about the LinkedIn feed, right? It's a very big analytics application. And of course, now at Rockset also, and my startup where I am, we also use ALT to kind of make sure we can give good performance. And similar, the last thing for real-time is that it also needs fast queries, right? So the first thing is needs fresh data, but it also needs fast queries because otherwise your system is slow. And then if you look at traditional approaches like MapReduce, MapReduce, which is mostly a batch system, they mostly use parallelize and scan, right? So let's say you're looking for a certain string in your book. Let's say you're reading a novel, right? And you want to find out the place where, I don't know, what is it? There's the Challenger space crash or whatever else. You're looking for a string. You have to scan through all the pages in the book to find where your data is, right?
Right.
This is, so if a query comes like that, the scanning method is good, but it's usually slow. But this is what MapReduce does. This is what essentially a lot of real-time and a lot of batch and streaming processes do. But the other idea is that you can optimize query by using something called indexing, right? So this is an index of a book. Take, for example, every big book that you have that you read, there's an index at the end of the book, right? So now if you go to the index to find this pattern you're looking for, and it is a page number, you can go to that book page number in the book and immediately find the page where your pattern is appearing. So indexing is a way to kind of make queries faster by building an index for the
so
which
means that you have to build the index ahead of time, pretty much like in a book. As you prepare the book, that you create the index. So you have to do the indexing ahead of time. That's assuming the content of the book is not also changing, correct?
No, you can build an index which is also changing. You see what I'm saying? But you have to build an index. That is the point. It's not about when a query comes in, you shouldn't have to scan every page again.
The whole page, all the book, right, correct. So
yes.
very simple idea.
You update the index.
The conceptually very simple idea, but it's a lot of value.
Very practical.
Very practical.
Yes, it's conceptually very simple, exactly. But this is the idea that is basically makes all queries fast. Is that always keep an index of your data. Queries should never have to scan your entire data set over and over.
And this is what is known as the famous key value store, basically. That's what it is, right?
Yeah, I mean, it can be used as a key value store.
Yeah,
but again, typically,
you're not doing value store yet. So this is all the indexing.
This is all internal to the system, right? Key value store is a poor man's database in my mind, right? It's a great thing, but it's because SQL wasn't there. Yeah, it's a poor man's database.
Okay.
But now people have moved on to SQL. you won't see new key value stores. This is my bet, is that you will not see any new key value stores going forward, because technology has improved so much that you can get the speed of a key value store using a SQL system.
Interesting.
I'll give an example. Like say, these are the two queries that are coming in, right? SQL, very simple way to express two queries. Select star from some table where this and that. Yeah, very declarative, very similar. Group by, having all this stuff. And so internally, it can use a key value store to store all the data.
Correct.
But each of the system automatically converts the SQL queries into the key value store, into the index, and then gives you fast results. So again, this is my bet, is that there'll be few key value stores, because key value stores were invented when all the web scale companies tried to do these things. And SQL hasn't improved that much yet, because they could get by with hiring a lot of engineers to be able to map all the applications to a key value store. That's a very complicated thing. SQL is so much useful because people can write SQL queries very quickly without having to know like a C++, Java, or some Python code to be written. So basically,
can you mention about the real-time and API connection on the previous slide?
Okay.
Real-time analytics and API, I think I saw at the bottom.
I think you're talking about this one?
Yeah, on the right-hand corner.
Okay. Yes, got it. So again, I'm comparing the traditional approach, which was the first one, MapReduce, which is mostly scanning, parallelizing and scanning. And the new real-time analytics, we still parallelize just like MapReduce, but we also index, basically. So use the index to find the values. And the applications and APIs essentially are, let's say you have a phone app, right? Or you have an app, like I gave you an example of fleet management. You have an app, you have a delivery to make. You cannot be, when a query goes to the backend, you cannot scan all the transactions that have happened and give you results. It has to be built in like a real-time system, so you can build an index and your queries return immediately from the backend. This is what I mean by application and APIs. These are applications that people use, let's say 10 times a minute or more than that, where the query volumes are high as well. Did I answer your question?
Thank you.
Okay. So yeah, it was mostly that instead of periodic reports, you already know what kind of reports you want to build. But applications and APIs, you don't know what the query would be. Some people might be looking for, how can I deliver this thing from San Jose to New Delhi within 3 days, right? So those queries are all different. So your backend has to be flexible enough to let people build all these applications and APIs. So that is essentially, I have one more slide, I think, talking about the future. So essentially, I think
before you go to the future, let me ask a couple of more questions about it.
Yes.
One is that, when you are doing this massive amount of data that you are trying to process and do it, how do you know that, what kind of ways you know that it's not working something? What ways you can, debug, for example, in a code point of view, or that something is not spitting out right? That's first question. Then I have a follow-up question when you answer that one.
Yeah. So I think you're talking about an analytics system, and you're trying to find out, is it giving the right answer?
Correct.
Right.
So,
this is the tough question. Exactly.
Very tough question. Right.
Very tough question, because it always gives you some answer. Right. Let's say you want to ship a box of sweets from San Jose to New Delhi, right? It will give an estimate saying that it will reach there in 5 days, but maybe it's wrong. Maybe it will reach in 10 days, right? And the focus of the software is to make sure it can estimate correctly and give you the right results. So most of the time, what we do, or most people do, is that there's something called A/B testing. A/B testing. I mean, there's kind of a lot of papers nowadays on this. So it's a question about
like a t-test.
Yes, exactly.
Yeah,
exactly.
Comparing two websites.
Exactly. So we have a model. Yeah, we have a model, and then we will maybe in the beginning we'll just run it in a dark kind of environment, which means that it doesn't give any estimates. It is giving estimates internally to people so that they can verify that the results are correct. And then we observe experiments of how long did this good take to get shipped from, say, San Jose to New Delhi. And we verify and refine the model. So there's a lot of A/B testing. And there are some A/B testing platforms and companies that are just now starting to build just these platforms for making it easy to do A/B testing.
I see.
And companies like Facebook, companies like Facebook, I'm talking about 8 years ago, we used to run probably 10,000 experiments every day.
I see.
Right. Okay. So those are all running in parallel, and the statistical samples also have to be statistically accurate.
Right. Correct.
So that one feature is not affecting the results. So there's a lot of thought going on to how to run all these tests and validating that answer is correct.
So that's
very complicated.
Yeah, that's what I was trying to get to. That part of doing is very, very important to be able to see.
Yes.
You cannot give for each specific one, but on a statistical sense, you can give a pretty good response to. The second question I have is slightly different, with a twist to that, is that as much as you try to customize something for what the user wants to see it, and it has as we have seen it with elections and everything, has a kind of a social implication that things can get sort of polarized. That was not intent, because I only see what I only see because I like sweets, I'm not, and then, so obviously the algorithm is doing what you are trying to do, but then you have to put some sort of some filters on it so that you can say that let's normalize this a little bit or whatever. So in a process like this, where did you put the normalization? Because you got these machines running, like the MapReduce picture you showed that, or the converged indexing that you talked about.
Yeah, this is a good question. So what has happened is that, like you said, the algorithms essentially reinforce the things you like and kind of make it less prominent for the things you don't like.
Right.
So there's more polarization about anything that whether the things that you're buying or the
it could be about just about food also. Just about food,
books, everything else.
Everything.
Yeah,
right.
everything else. Everything else. So, I mean, again, I think just talking about social media, I think it is possible that they could have two different modes of operation, where there's one mode which is basically look at nothing that my tastes are and just give you a general purpose recommendation of the books that you want to read or the food that you want to read. So again, I think that is very much on the application to be able to do this and giving people an opportunity or like an option to be able to do that. Because it's like reading a newspaper, right? You don't have choice on what the newspaper is printing. So you pick it up from the front door and you read whatever is there and you skip over things that you don't like. So I think for all of those, I think again, real timeliness is definitely needed because you want to read recent news, right?
Correct.
It has to be real time. So irrespective of whether you do personalization or you don't do personalization, I think real time is important, but personalization is needed for some things. And then for many applications, I agree with you, then maybe it's just easy to give an opt-out saying that I will show you a non-personalized feed. I think there's a lot of value for that as well. Right? Do you agree?
Yeah. No, there's a value to it. I mean, we are learning it through all of it in a sense, this thing that you can almost say that, another way to look at this thing is that we say that, okay, for any human being that you want to give, let's say, I don't know, I'll pick a number, 80% of the things you want, 20% you put generic information. Because we don't know.
No, that is already there, I think. I think that model, at least in Facebook, already there is a certain percentage. Again, I don't know exactly what the percentage is, but there is a random mix. But I think the random mix is not big enough to be able to make much impact.
Correct, right. That itself is an interesting problem in itself. What's the good mix? I guess the point I'm trying to make it is that that ratio is some sort of a ratio is there, as you say, some random, but it's not sufficient. So you don't know what the good balance it is for what to do. But the question for that is that in this kind of a system, where do we put that the fraction. Let's say we put 20% as a random information to me. Where in the processing part of this whole thing you're going to put that in? We're going to put it in the beginning.
Oh, I see. So this is, yeah. So I think what happens is that, yeah, from the tech perspective, I think it is at a model building stage. So when you're building a model, the model has like maybe 10,000 parameters or features to that model. So I think the weight is, and every feature. So in technical terms, like a model has lots of features, which are basically inputs to the model.
Right.
And so there's also usually there's a weightage given to every feature. And the way they are combined. The way the features are combined is essentially the code in the model. So it's great to be able to give appropriate weightage for each of these features. Again, there's no one answer. I think it very much depends on the model.
I guess what I was trying to get to is that somewhere in the process, there's some sort of machine learning thing is going on, independent of the analytics engine you talked about. So that gives you that. So that itself is that, allows you to do those things. That's what I said. That my point is just for the general audience to say that, when you look at the analytics, what Dhruba, you're covering is more the data processing part of it to get a thing. But there are other things happening to make the whole thing work, in terms of the machine learning to parameterize the weights and determining what should be the right word, some of these are running. Just kind of, that's my point. Basically.
A lot of mathematical and statistical reasoning. I wouldn't say theory, but reasoning.
Absolutely. Right.
And those things happen in batch and more in big volumes, because that's how you can find new models and new features.
Exactly. That you
they don't have to be real time.
They don't
need to be real time.
No, they don't need to be real time. So the many things are going behind the system. That's basically what it is, right? So,
yes. Yep. Right. Exactly.
Black books.
Okay, so you're going to talk about the next step now.
I mean, I had just one or two small things.
That's very good. We're very good. We are about 15 minutes or so. Good. We have about 5-10 minutes.
So I think I just had an opinion on how I think the future of this data set is or data analytics is going in general. So I like your idea where key value stores were definitely giving low latency queries.
Right.
And I think that stays with data. So either it's a key value store or some other system, but everybody wants low latency. That's where I see a lot of, and I also see a lot of APIs and applications that you asked, right? How APIs and applications, because when APIs and applications use data analytics, usually the query volume is very high. QPS is like queries per second. Because lots of people are using it and lots of applications are using it. It's not a reporting application which produces a report once every hour. So that's where data analytics is going. And then again, low data latency, which means that you want to make analytics on the most recent data.
Correct.
You don't want to wait and accumulate data for many minutes before you try to get analytics out of it. So I mean, that's where my heart and mind is right now these days, how to make real-time analytics successful and make it better.
Very useful for healthcare too.
Yes, I see a lot of users. I see a lot of users using real-time analytics in real life.
So let me ask. That's very interesting. So let me kind of step back to a couple of things you have worked on. So to kind of say, you at Facebook, you were the founding engineer on the RocksDB. So what led you to create RocksDB? What went through your mind? So I'm picking your brain, basically.
Yes.
So,
right. No, absolutely. That's great.
So what made you to think about that, and what was it trying to solve? I think so.
Got it. Yeah. No, great question. So before RocksDB happened, we were using a system called HBase. It's a Hadoop database. And what I saw is that, so Hadoop database essentially ran on hard disks where data was stored in spinning media and things like that. And then what happened around 2011, I think, is when a lot of people moved to some different media called flash media, which is basically very fast access to data storage. And then I realized that all the HBase clusters or the Hadoop databases that are running, those were not optimized to run on this new hardware that is coming up. So it's like new hardware, like for a consumer, it could be like, let's say you buy a new iPhone 13, right? That's new hardware compared to the iPhone 1. So in the backend systems, also new hardware came up like flash drives. And I thought that there is a different way to build software which can actually make the backend databases go like 100x faster. So I remember the first time we built RocksDB, myself, I started it, and then 2 other people joined my team. And then we built a prototype and we replaced like a 500 node HBase cluster with like an 8 node RocksDB cluster. So 500 Hadoop machines got replaced by like 8 nodes of RocksDB. So that's the time when other people in the company thought, oh, this is good technology. Let me also try this and see how it works.
I see.
So the whole point was to build something as a prototype and also put it into production for some use cases, so that you can show value, because the best value comes when your customers tell that it's a good thing rather than you telling that, oh, what I built is great. Right. That doesn't usually work. It's only when a customer says that, oh, this is adding value, then other people listen to that software. So, so that's what happened at Facebook. And the Facebook management was very open-minded to saying, yeah, let's try some new technology and see how to make it better. So there's always an experimentation mindset. It was okay for projects to fail and not work. And as an engineer, you never got punished saying that, oh, you built a project that was not useful. So it let people take chances and build new software.
Okay. I see.
Yeah,
no, that's very, very good. Because, you think about something, sometimes, I guess what I was going to get to is that sometimes you have to, this sort of things happens, you think out of the box a little bit and kind of say that something is not working as well as you like. You just have to do something very, very differently. That's sort of what it is, basically.
Absolutely. Especially when environment changes, right? Like in that case, the hardware changed. So the platform changes. That's a great way for you to think, what can you do differently?
Right. Very, very good. Yeah. Excellent. So now
same thing happened with Hadoop as well. Yeah, go ahead.
Okay. The final thing is going to be that what are you trying to do with Rockset right now? You talk about real-time analytics like fleet management and everything, but what ways are you productizing your knowledge base, basically, to be able to make a product that you feel like that there's probably potential customers who can use it?
Okay. Yeah, I think so. The motivation for me is that I think real-time analytics adds a lot of value to the normal day-to-day life of each one of us. I compare this with, say, how real-time streaming happened, right? Earlier times, I used to go to the video store to get a DVD on like Friday and then watch it on Saturday, right? But nowadays, I just switch on the TV and say, hey, let us stream some movies. Right. So I feel like application developers are also moving to this model where they don't have to plan things in 10 days in advance. They can leverage the data as and when it is there, and build applications immediately without having to clear up this data, clean this data, make it like batch it and do lots of schematization before they can make use of it. So real-time analytics plays a big part in this, is that you have a data that is constantly coming in, and you as an application developer or an API developer, you don't have to go talk to other people and say, hey, give me this data, give me access to this data, make it in this format. None of that, because Rockset lets you access the data in any format the data is. You can access it through SQL without creating a schema, without creating cleaning up all your data. And you can start making SQL queries on completely semi-structured data without having to create tables and everything else. So the focus again is that how can we enable application developers to run fast with a lot of data?
I see.
And when our customers use it, I like it when they say that, oh, Rockset shrunk my 6-month project to 1 week.
I see.
The customer is not talking about the technology. He's least bothered about
Yeah,
the
least
technology
bothered
behind
about it.
right? He's least bothered about it.
For the
He's just saying that,
customer, the
my
value is
6-month
the
project,
time and money, you know.
time and money. Exactly. Yeah. So the
Right.
value is the time and money. And especially when you have a lot of data,
Mhm.
keeping the data system up and alive is a lot of cost for the customer in general, right? They spend a lot of people and systems
Mhm.
handling these large data sets. So
Mhm.
Rockset adds value because you can take semi-structured data and you can just start making SQL queries on it immediately.
Very interesting. Okay.
So that's
Fantastic.
what motivates me. I feel good when the people is telling me why they're using
Mhm.
it, and the answer doesn't have to do with anything with technology.
Absolutely not. Yeah,
So,
right. Technology doesn't matter at that point, you know. It's like a
right.
car, it runs better, you know.
Exactly. It's exactly.
So,
Yeah.
yeah.
In
Who cares
layman's
about what
term, right? I always think about the layman.
Yeah,
Right.
exactly.
Exactly.
Yeah.
Mhm. What can it improve? Very good. Do you have any parting thoughts, Dhruba, before we close the session?
No, I hope
I had a question
this was
there
interesting to you. Yeah. Shakunta, do you
on
have
the
a
chat.
question?
I had a
Oh, there are
question
some
for
questions.
Oh, I must have missed it. Did you have another question? Oh,
Yeah, about
Yeah.
can you do
you talk
real-time?
about structured data, computer vision, unstructured. How text mining? Can that be done
Great
in
question.
batch like this? For
Yeah,
document
great
reading,
question.
like
Yeah, no, I think it's a great question. So natural language processing, right? I think that is
yeah,
very similar to the video processing app that I showed you, right? Where the data is kind of very analog format, right? I mean, but you have to digitize it before you can actually kind of make sense out of it. So real time, again, I think is super important for any use case. It doesn't matter whether it's audio, whether it's video, or whether it is an analytics use case. And the systems that we have built kind of helps in most of these. But of course, you have to change the audio analog signals to digital so that you can have like an array of numbers to represent, say, a video frame, or an array of numbers to represent an audio frame. You might need more things than what a real-time analytics system offers, because you might need similarity search. You might need some other kinds of searching algorithms. But those could be built on top of some of
but
these
it's like
systems that
the
I described.
linkage thing you showed, like people linkage at Facebook. So this could be concept
Yes,
linkage. You
that's
tie
true.
the context.
That's true.
Okay.
Yeah, that's definitely true. Yeah, no, that's definitely.
Yeah, it's wonderful. Thank you. We'll keep in
Sure,
touch.
yeah. Yeah, absolutely.
All
Thanks
right.
for the question.
Let
Was
me
there
see
any-
if anybody else have any question in the chat, or you can unmute yourself if you want to join. If nobody else have any questions, we're going to stop it soon then. So
Cool. Yeah, please send me questions offline also if you have. My email address will be there in my slides.
great. Thank you very much, Dhruba, for joining today and giving a very enlightening talk. And as I said, we are recording this thing and it will be made available on YouTube. Also, we have on our Facebook page, it will be there. So for, anybody to learn more about things like this, so thanks again for joining today and giving your talk.